from sunny Leicester. Amazing. Great. Hi, Marcus. How are you doing?
Hello.
Hello. Awesome. So we have our lovely crowd of hackers. Everyone. So this is our last official workshop, I guess, of the series of this hackathon. So we are joined by Marcus from the Digital Identity Foundation, and he will be going over Universal Resolver and Universal Registrar. Thank you for making it here. Happy Monday, everyone. And I'll stop speaking now and let Marcus get stuck into it. Cool. Are you good to share your screen?
Yes.
Awesome.
Thanks. I will go ahead and do that. All right. Can you see that?
Yes, perfect.
Okay, then let's get started. Thanks for the introduction and welcome everyone. I can wait. Can I see a list of participants? I'm just curious how many people we are here. I can see the chat. Is there a way to see a list of participants or?
No, it's kind of just everyone in the chat.
Okay, that's fine. No problem. Then yeah, let's get started. I'll quickly introduce myself and the topic. As you said, I'm with Marcus Sabatello, founder of a company called Tech in Vienna. We work on a lot of things related to decentralized identity, and also quite active in DIF. That's the Decentralized Identity Foundation, not the Digital Identity Foundation. So DIF is an organization where a lot of companies and individuals come together to work on common ideas or interesting topics that have to do with decentralized identity architectures and ecosystems and technologies. And in DIF, I'm a member of the steering committee and also co-chair of one of the working groups. And to be more precise, here's one of the working groups, Identifiers and Discovery Working Group, which I am chairing. This is a working group that has existed since the beginning of DIF, so it has always been active as one part of DIF. And it's a working group that, as the name says, has to do with identifiers, right? How do we identify things? How do we refer to individuals, organizations, and things? How do we create and use digital addresses? Because we say this is a basis for everything else, right? So if we want to share personal data, if we want to create connections, if we want to exchange messages, we always need identifiers. We always need ways how we can refer and to each other and establish communication channels. So that's the basic idea of this working group, Identifiers and Discovery. And today, specifically, the topic of the workshop is Universal Resolver and Universal Registrar. Those are two open source projects in DIF. So these are two concrete work items within this working group, Identifiers and Discovery working group. If you go to this website, actually, you will see a list of work items. In DIF, we work on technical specifications, technical documents, but also open source components and libraries. And you can see here in the list, the first two items say Universal Resolver, Universal Registrar. So these are the two components managed by DIF that we will talk about. And in terms of organizing the workshop, I mean, I've I've prepared a few slides. I can do a few demos, but it's of course also fine to just talk about whatever people are interested in. If you have any questions or any concrete things you want to try or you will want to try out and try to do, or if you've maybe already tried these tools and you have some questions about that, I'm happy to make this very flexible, or just interrupt me. I will try to monitor the chat a little bit. So yeah, we can make this very dynamic and spontaneous if there are any questions. Maybe one question I have, or what I don't really know so much yet, is to what extent do people here on the workshop, on the call, already know some of the basic technologies, right? Like DIDs. I'm not sure if I should spend a lot of time talking about that, if people already know what that is, but maybe just a quick introduction, because this is what the two open source projects are all about. Decentralized identifiers, DIDs, are basically a foundation, a basic building block for a lot of other technologies and a lot of applications and services that are being built in the decentralized identity community. So when we talk about decentralized identity, first of all, what does that mean? It means that we can exchange identity information, we can exchange personal data, we can log into websites, we can prove online what we are. We can do all of these things without a dependency on a central authority or intermediary, right? That's what we mean by decentralized identity, sometimes also known as self-sovereign identity, SSI. And there are a lot of technologies, a lot of building blocks that are available to implement this, to realize this vision of a decentralized identity infrastructure. And one of the basic foundational building blocks is this here, the DIDs, right? So the idea is that in order to build decentralized identity, we first need decentralized identifiers, so that, again, we can connect to each other, we can refer to each other, we have addresses that we can use to identify each other, and when we can do all of that without a central database, right? Like a Facebook username, that is not a decentralized identifier, or a social security number is not a decentralized identifier, or a domain name is not a decentralized identifier, because all these things are managed by some kind of central authority. And that's why DIDs were invented and standardized. So they are now a W3C standard. So they are standard at the World Wide Web Consortium. That's the most important standards organization for the web. And these DIDs have been officially standardized. There's a question like a global passport. No, it's not so much like a global passport, because the DID by itself, if you look at it, this here is an example of what it looks like, and this does not contain any personal information, right? So the DID, you can think of that as a pseudonymous address, a little bit like a public key, a cryptographic key, or a cryptographic hash, or usually almost like a random number. The DID by itself doesn't really tell you much about the subject that is identified by the DID. So, and this is unique as a technology, because you can create these DIDs on your own. So you don't have to go to some provider and buy a DID, or you don't have to get it issued to you by your government or by a company. But technically speaking, you can create this by yourself, and you don't have to provide your first name or last name or birth certificate or any of that. So it's like a decentralized pseudonymous identifier. There's no central registry for this. Anyone can create these. And one thing that's also important to mention here is something called a method. So what this means is that this is essentially something like a type of DID. There are many different types of DIDs. How exactly they are created and used. So there are different underlying infrastructures, how these DIDs get established and then used. Sometimes they are created using some blockchain technology like Bitcoin or Ethereum. Sometimes DIDs get created through some other kind of decentralized network. Sometimes they get created just on a local environment. So there are also types of DIDs that just exist locally, that are not really registered anywhere in the public infrastructure. And then there are also some DID methods that are not as decentralized as the name would suggest, right? So there are also types of DIDs that do actually depend on some kind of central infrastructure, which contradicts the concept a little bit. But what's important to understand is that DIDs in a way are some kind of abstraction layer where identifiers can exist in different underlying infrastructures, but they are designed to work without without a central registry where they get created and maintained. How are they being used? So I have just one slide to try to explain that the DIDs by themselves are not very useful, right? So with a DID by itself, an end user can't really do anything, and end users, if you download a mobile app on your phone, or you use some kind of web service that supports decentralized identity technologies, then usually as the end user you would not see these DIDs. This is relatively low level technology that happens behind the scenes, right? A little bit like when you browse the web, when you open some web page, or when you send an email, you typically don't see the underlying IP addresses, right? The IP addresses is something underneath that makes everything work, that makes the communication work, but you as an end user, you don't have to worry about them. And with DIDs are also intended to be a little bit like that, a low-level technical address, an identifier that makes other things work, right? But that isn't immediately useful only by itself. And here are some examples of what they can, where they are used, or what other things are being built using DIDs so that they then become useful. And one example is verifiable credentials, which is another very important technology, also standardized at the World Wide Web Consortium. And verifiable credential is now a machine-readable set of attributes or semantic statements about a subject, right? So the DID by itself kind of looks like this. I said looks random, looks like a pseudonymous identifier, doesn't really tell you anything about who's behind it. But together with another technology called verifiable credentials, the DIDs it now becomes possible to make concrete statements about a subject. So with a verifiable credential, you can express digital documents or attributes like a mobile driver's license, or a digital diploma, or a passport, right? So in the chat, the topic of a passport was mentioned. So a passport could be expressed as a verifiable credential, and in these verifiable credentials, there's usually an issuer and a subject, right? So there's somebody who makes a statement about something. It could be a government who makes a statement about you that you are allowed to drive cars, or it could be a university making a statement about you that you graduated from a certain course and earned a certain degree. And this is where the DIDs are used, right? So if we say that DIDs by themselves are not so useful or not useful by themselves, but as part of these verifiable credentials, they become useful, because the university could issue to me a digital diploma, a degree. The university makes a statement that I passed a certain course, and then in this digital statement, in this verifiable credential, we have an issuer, which is the university, identified by a DID statement about a subject, which is me, which is again, in this case, I am again identified by a DID. So this is one example. Another one is, let me mention this first here, service discovery. So this is a way how to look up somebody's associated services, digital services, like a social media a network, or an XMPP messaging service, or some other kind of mechanism for interacting with someone. If I'm not mistaken, I think there was already another workshop about DITCOM. Is that right? So DITCOM is a general purpose communication mechanism, right, where I can establish a digital connection with you, with my friend, with a company, with the government. And in this DITCOM connection, both sides of the connection are identified with a DID. And I can use the DID to look up somebody's DITCOM service, and then I'm able to connect to them. So this is a second important function of DIDs, to be able to discover someone, to discover somebody's endpoint, how to interact with them. And DIDs then also enable a secure, authenticated and encrypted connection. One question was if there can be multiple credentials. Yes, of course. So there can be many types of these verifiable credentials issued by someone to someone else, and that's where the whole concept of digital wallets come in, right? A lot of people are talking about wallets. So a wallet would be a concrete piece of software that a user could have on their smartphone, and the wallet contains your verifiable credential. The wallet also manages your DIDs, and the wallet can of course hold multiple of these credentials. And one other relatively simple function of DIDs is also just authenticating. So one thing that's special also about these DIDs as a type of identifier is that there's always a way to cryptographically prove that you control a DID, right? So DIDs always have this built-in notion of control. It's not like a UUID, for example. If you're familiar with UUIDs are just random numbers and those are also useful identifiers, but they are not owned or controlled by anyone. They're just random strings, whereas DIDs always have some associated cryptographic key pairs that allow the holder to control their DIDs, which is an interesting technical feature. And one thing that this enables is basically just at any time prove that you control your DID, and this can be used and is being used, for example, to just build authentication protocols. So you could log into a website with your DID, right? There are not many websites maybe that support this today, but conceptually, you can log in somewhere, authenticate somewhere with your DID, and for that you need some kind of protocol like OpenID Connect. But conceptually, this is something that's possible with DID, so that you can log into a website not with a username and password, but with your DID, which is decentralized and only belongs to you. So this is just some motivation and introduction, I guess, for what DIDs are used for. And if, let me see, are there any questions at this point? Okay, these are relatively broad questions. Let me maybe, oops. What commercial projects are currently using DIDs? There are many projects all over the world that are being implemented right now. In the United States, there's a initiative by the Department of Homeland Security. They are working on a digital version of the green card, for example. So if you're an immigrant and you want to live and work in the US, then there's going to be, probably in the next few years when that is fully implemented, a way for you to have your green card in a digital wallet in the form of a verifiable credential based on DIDs. And here in the European Union, there are also a lot of projects and use cases around digital diplomas. If you graduate from a university, then you could get your diploma issued using these technologies. Social security passes, travel-related use cases. Imagine your boarding pass for an airplane, for example, issued to your DID. And also in other parts of the world, Australia, South Korea, South Africa, there are projects happening everywhere that are going to adopt this. Security issues and limitations is also one of the questions. It's a very broad topic. I would suggest to maybe cover that at the end. There's also, if you look up decentralized identifiers at the World Wide Web Consortium, you will find the standard, the technical specification, and that also has a section about security considerations. Maybe one thing I'll mention is that since DIDs are controlled by private keys, cryptographic keys, there is one very important security aspect is of what happens when you lose your private keys, right? So this is a technology that is inherently decentralized, which means that if you lose control of this DID, then there's no website where you can go and you can click on I forgot my password, because nobody other than you has the private key, right? So that's one thing to keep in mind from a security perspective, but there are also lots of ideas on how that can be addressed or to create some kind of backup and recovery mechanisms so that you don't lose everything about your digital identity. But I'd like to get to the actual open source project, since this was just introduction. Here's just one more introduction slide about DID resolution. So this is now the most important technical process that DIDs provide, or that is enabled by DIDs. And it means to look up metadata associated with the DID. So the DID looks something like this. For example, we've already seen that before. In this case, it says DID : EBSI : and then some random looking string. Remember this second part of the identifier here, EBSI, this is the DID method. This tells us where and how exactly this decentralized identifier has been created and where it exists. In this case, EBSI stands for European Blockchain Service Infrastructure. This is a technical blockchain infrastructure here in the EU. And when you have this identifier, when you see this DID, this DID, then you can resolve it. And resolving means looking up this type of document here called the DID document. And this has metadata about the subject, technical metadata. So again, this does not contain personal data, first name, last name, or date of birth. Remember that was in a different technology called the verifiable credentials. But here on the level of the DIDs, you have associated DID documents, and this contains technical metadata like public keys, cryptographic public keys, and service endpoints. For example, here a decentralized web node endpoint or a DIDCOM endpoint. or something else. And the idea is that if I give my DID to one of you, or if we somehow exchange DIDs, of course you should not imagine that in a literal sense, right? I'm not going to write down my DID on a piece of paper and give it to you, or send it to you in an email. But DIDs can be exchanged, for example, in the form of links on a website, or they can be exchanged in the form of QR codes. So we scan each other's QR code to exchange these DIDs, and then with that we can look up this DID document, this kind of metadata. And again, this contains public keys. That's called here verification methods, and it contains service endpoints. And this is the basic technical metadata that is needed so that we can interact and establish connections, look up each other's DIDCOM endpoint, verify each other's credentials, authenticate to each other, log into websites, the kinds of things I talked about before. All of that is enabled by this metadata, and looking up this information from the DID, that is called DID resolution. So that is the process of DID resolution. It's maybe a little bit similar to the DNS resolution, right? If you have a domain name, then you can look up the associated IP address. And so here in this case, if you have a DID, then you can look up the associated DID document. And let me see any questions. Not right now. And so this function is really very fundamental, and exists and is the basis for a lot of other things. And there are also many. I'll skip to another slide quickly. There are also many code bases and open source implementations that can be used to perform this function, to resolve a DID, to look up the DID document for a DID. Here you can see some examples, Veramo framework, Hyperledger Aries, there's a TypeScript implementation, Spruce DIDKit. And then of course we have our DIF universal resolver, which we have in the name here of the workshop. So this is the open source implementation of DID resolution, of this basic technical function. So here's a quick diagram, and there's a second open source project also called Universal Registrar. So that is the actual topic of the presentation here, right? These are two open source project. Yes, of course we can share the presentation afterwards. So Universal Resolver and Universal Registrar are two open source projects at DIF, and Universal Resolver performs the DID resolution function, and Universal Registrar I will talk about a little bit later, but this is basically a project for creating and updating and managing DIDs. And okay, I'll switch to another window now, and I will actually show you this Universal Resolver project. First of all, here is again the website of the GitHub repository of our identifiers and discovery working group at DIF. Here's one work item, which is the Universal Resolver, and here's a link to the GitHub repository of this Universal Resolver. It has some documentation, some explanation, and once you run it, it looks like this. So this is what a simple front end looks like for this Universal Resolver, and it performs this DID resolution function. And what's special about it maybe is that it tries to support a lot of these different DID methods, right? So remember I was talking about DID methods and how these DIDs can exist in different infrastructures, sometimes blockchain, sometimes not blockchain. And there are different types of these DID methods, and the universal resolver is called universal resolver because it tries to support many of these. And you can see here in the drop-down list a lot of examples, right? They may not all work all the time. You can also see some color coding here. So some of these colors mean that not everything is working all the time, but in principle, I can put here in this field a DID, like an EBSI DID, and then I can click here on resolve, and then the result is this DID document, right? This technical metadata. So given this address, this EBSI DID, the result is this DID document. And if I try it with a different identifier, let me try this one maybe. Then again, I get the document, and it looks a little bit different. The structure is a little bit different, but the basic function is always the same. The input is a DID, and the output is the DID document. And again, this is something that's not directly it's not directly meant for an end user, right? Nobody wakes up in the morning and says, "Oh, I want to resolve some DIDs today because that's so much fun." No, it's not like that, but it happens behind the scenes for a lot of other building blocks and technologies. Are there any implementations for healthcare standards? I'm not sure right now. I'd have to look that up, do some research on that. I'm sure there are also projects in the healthcare community that use this, but I have to look it up. Here in the EU, I'm aware of some projects that have to do with social security passes. Healthcare, I'm not sure right now, but in principle, I think this technology or this approach to digital identity would be very well suited for healthcare because it's a very privacy preserving approach, right? Where digital identity is under the control of the individual, and there's not a central aggregator that can collect all the data in the world. So in theory, I think it's especially well suited for sensitive data, for like healthcare data. I'm sorry, I'm just going to turn on the light for a moment because it's getting dark here, and I'm back. So I'd be happy to look that up. And somebody tried it. Lucas tried it with the ENS example, and it worked. That's good. So yeah, ENS. I mean, what's also interesting about DIDs to understand is that because there are these DID methods, right? Like ENS, DIDs can also be, or a DID method can also be designed on top of some already existing identifier standard or technology, right? ENS is something that was developed completely independently. ENS is not the Ethereum naming system, I think, was not specifically developed with DIDs in mind, but because DIDs are designed to be this kind of abstraction layer, it's possible to fit existing identifier standards also into this pattern, into this interface. And let's see, how much time do we have left? Still a little bit. So one thing, or a few things that are important. Again, first of all, this is not something that really an end user would directly access. This front end, this user interface that you see here is also meant for developers, right? In an actual concrete use case or in a concrete scenario, this would be accessed through an API, right? So usually there are some other components like a DITCOM agent or a verifiable credential issuer or verifier component, or some other piece of functionality that's actually useful for the end user that provides a concrete function, but that uses DID resolution behind the scenes, right? So this universal resolver is really meant to expose an API, which can then be integrated with other things. It's not something that people would use as a standalone thing. Another thing to point out is that the website that you're looking at right now, dev.uniresolver.io, this is one instance of the universal resolver, which is hosted and provided by DIF. But if you click here on this orange warning button, it will say that this public instance is not designed to be very reliable or very scalable. This is utility for developers, but when this is deployed or used for some production use case, for some actual real life application, then this should be self-hosted, right? So this is an open source project at DIF. Anyone can download this software in the form of Docker images, and it can be easily deployed on your own IT infrastructure, right? Because if everybody were to use this instance here, dev.uniresolver.io, well, that would sort of defeat the idea of decentralized identity, because now you would be dependent on this one central service. So the idea is that this can be and should be self-hosted, and maybe one other thing to mention, if I look again quickly at a list of different implementations. So there are different code bases that support DID resolution, and the way how DID resolution can also work sometimes is that some of these libraries, some of these SDKs, like Hyperledger Aries, for example, are capable of resolving DIDs. So you don't always need this DIF universal resolver project, because there are many implementations of decentralized identity that can resolve DIDs. But usually they don't support as many different types of DIDs as this universal resolver, right? So again, that is the strength or the value proposition of this project, to try to support here many different types of ecosystems and infrastructures. Actually, I should have prepared a little bit better, and I should have looked up the Onyx implementation, right, by JP Morgan, because the workshop or this hackathon is sponsored and supported by them, right? So that's also a really nice SSI SDK for decentralized identity, and this code base also supports DIDs, but it says it supports two different DID methods, right? So this supports DID key and DID ether, which is really nice. And for some applications and some use cases, this may be more than enough. But if you have a use case or an application where you want very broad interoperability, then you could still use the Onyx SSI SDK, but you might want to connect it or use it in conjunction with the DIF universal resolver, because then suddenly, instead of 2 different DID methods, you can support 50 different DID methods, right? And sometimes this makes sense, and sometimes this doesn't make sense. But just to explain a little bit how this is intended to be used and fit in with other things. Maybe I don't know, I feel like I would like to pause a little bit and see if there are any questions, if anybody has had anything in mind when joining this session, or anything that people on the call are considering to work on, or use cases.
I guess not at the moment.
That's fine. I mean, if people are trying out deeds, or if you have any deeds, you can also put them in the chat and share with others. I guess I will. Yeah, just right. I could have also just put the links here into the chat, and if there are no questions, then we'll quickly talk about the other project, right? Universal Registrar, because that's also the subject of the workshop here. So Universal Registrar is a second open source project at DIF. I will actually also open that here in my web browser, and put it in the chat also. So this is basically a very similar project, a similar idea. It also tries to, it also creates an abstraction layer, a universal interface for deeds. But this time it's not about resolving deeds. It's not about looking up a deed document for a deed, but this is for creating and updating and deactivating deeds. And I will say this is, as a project, this is a bit more experimental. If you try some things out here, not everything may work right away. Some of the functionality requires some configuration. It may require that you deploy this on your own and set it up and initialize it by yourself. But conceptually, again, the idea is that you can not resolve, but create and update and deactivate the IDs, again, across these different deed methods using a single universal API. So you could use this to create a deed key identifier, deed ion identifier, deed web, deed EBSI, deed solved, deed ether, deed checked, deed BTCR. You also see this is a smaller number of deed methods, right? These are 10 different deed methods, whereas the Universal Resolver supports about 50. And the interface, the API of this is also a bit more complex, right? So if, let's say, I want to create a deed using this deed solve method, it's a bit more complicated. The input is not just the deed itself, but as an input to this API, you have to provide a few additional things. You provide the initial deed document that you want to have for the new deed. Remember that the document contains public keys and service endpoints, and you can provide some options, and you can provide some secrets, like for some of the deed methods, you need something like an onboarding token or an access token. So this is a bit more complex, but in theory or conceptually, this also provides a single universal API, which then allows you to create deeds in all these different networks, whether it's Ethereum blockchain or checked or ion or deed web or deed key. And let me just quickly try that. I click here on create, and then you can see there's a result. So here is a new deed now that was just created, deed solve. Then this here means that it was created on a test network, so not really a production ready network, but still this is an actual deed that can now also be resolved, right? So I could copy this, and I could then use the universal resolver I go back here and look this up, and then it will return the documents. It was successfully created and then resolved. One aspect, well, let me just quickly also demonstrate this with another DID method. So I just did this using the DID solve method. This is a type of DID that is created on Sovereign, which is a network based on the Hyperledger Indy distributed ledger technology. And if I do the same thing with the DID key method, for example, DID key is a very simple DID method. These are DIDs that are only created locally, and they are not registered or stored on some kind of blockchain. They are just created in a local environment. But with this universal registrar project, I can create a DID solve DID or create a DID key DID, basically using the same API, using the same interface, even though the underlying technology between different DID methods is very different. So here I just created a DID using this DID key method. And one thing that you may be wondering, if you look at this very closely, if you're already familiar with this technology a little bit, you will see that when I create a DID, then as I mentioned in the beginning, also DIDs always have a built-in concept of control, right? DIDs are always have some associated key pairs, private keys and public keys that control the DID. And so when I create a DID, when I create a new DID, then there also needs to be a new key pair that gets created. And in the early version of this universal registrar project, when we started to create this, we built it in a way where this universal registrar is hosted as a service. And when you call the API, it will create a new DID for you, and it will also create the keys for you that control the DID. And then it will return the private keys to you. So that's why here in the response, what you see here, if you know these formats a little bit, you will see that the private key, which controls the DID, is actually returned back to the client, and it was the same in the previous example. So one final point, I think, in the technical explanation that I want to make here is that what I just explained is what's here in this diagram on the left side, where there's a client who calls this universal registrar service, and this creates the DIDs and takes care of everything, and then it returns the private keys to the client. Of course, from a security perspective, this is really bad, right? Because from a security point of view, the whole idea of private keys is that you're the only one who has them, right? The private keys in a decentralized identity ecosystem should be created locally in your own wallet, and they should not be created by some service for you. So that's why in this universal registrar project, we've also worked on an architecture which you see here on the right, which maybe I'll make this a little bit bigger, which we call this client managed secret mode. And I don't want to go too much into detail because we don't have that much time, but what this means is that you can have a client like a wallet on a smartphone, for example, a client component, which calls the universal registrar service. And this universal registrar will take care of all the DID-specific operations. It will create a sovereign DID or EPSI DID or Indy DID or checked DID, all these different types of DIDs, and it will do everything. It will construct the correct messages. It will communicate with blockchains, whatever is necessary. It will do all of that, except for the cryptographic key operations, right? So the generation of key pairs, the signing of payloads using keys for signing something, generating private keys, all of that happens on the client side. Again, we call that client managed secret mode. And so it basically separates cryptographic key operations from DID operations. So you still get the benefit of being able to create and manage DIDs across all these different DID methods, Ethereum, Ion, checked, EBSI, and so on. You don't have to worry about all the specifics of these different types of DIDs, but all the cryptographic key operations still happen on the client side. And again, this is of course not something that an end user would perform on their own. This is also not so easy for me to demonstrate here in a user interface, because I would have to construct these different options and secrets, or different input fields in this protocol. I would have to construct them correctly. I would have to perform some cryptographic key operations on a command line with OpenSSL or tools like that. So this is not easy to perform here live and manually. But again, just like the universal resolver, universal registrar is also meant to be used not by an end user, but to be integrated with other tools and other applications. So I could imagine, for example, also extending this Onyx SSI kit. This could be theoretically integrated with the universal resolver service and universal registrar service to then support many more DID methods than it supports right now, but still with the private keys under the control of the client, of the holder. And then again, DIDs are just the foundation for a lot of other things. Then all sorts of cool higher level functionalities can be built on top of that, like verifiable credentials, DIDCOM, OpenID Connect, and so on. And now I'll stop again for a few minutes, because I imagine this may not have been so simple. I'd be really curious if anybody has some thoughts or something in mind that you're trying to build, or something that you're working on, or some questions that anyone has.
I don't think there are any questions yet. I think everyone is shy to share what they're building. I know some of you must have some ideas, / I know some of your names, and I know that you guys have ideas. So please do share. And if you're still in the audience as well, please to drop a little message, at least to give us a bit of feedback, give us an emoji or something if you've enjoyed this workshop so far.
Guardian system for private keys. Yes, of course. That sounds great, right? Because DIDs always require private keys, and when you lose your private key, then you lose control of your DID. It's a little bit like a Bitcoin address, right? If you have Bitcoins on your, and I don't work really with Bitcoin or cryptocurrencies. I don't have much experience with that, but technically, a DID is not so different from a cryptocurrency address where you have to control your private key, right? And if you want to, or if you manage somebody else's identifiers, so the guardianship example, if I'm a parent and I want to manage my child's digital identity, then I may control the private keys for a DID that doesn't identify me, but that identifies my child. And there are also architectures where you can, I mean, this is a bit sensitive maybe, but in theory, you could also have a hosted wallet, right? If you think you can't manage your private keys by yourself, then of course a hosted service could also manage a wallet for you and manage your DIDs and your verifiable credentials for you. That exists as well, just like you have it in the Bitcoin world, right? You also have hosted wallets, but then of course it means that it's not as decentralized as it's meant to be, and then it means that there's somebody who theoretically could take the key away from you and impersonate you. Wish you could share a sample tab using DIT. I'm not sure if I can think of something. Yeah, these projects again are relatively low level, right? These are not end-to-end apps. A sample app, I'll think of something.
Feel free to share it with me afterwards, Marcus, if you can think of it, and I'll pass it on.
I know that, for example, the decentralized web node community, DWNs, right? This is being built by a company called Block and a community called TBD. They're building something called decentralized web nodes, which is something like a personal data store where you can store your data and then share it with others and create connections, and all of that is based on DIT, so the DITs are used for the connections. And one sample app that they have demonstrated at a major Bitcoin conference is a decentralized playlist for music, right? So that they showed how in a decentralized web node you can store your favorite songs and your playlist and what you're listening to, and you can grant your friends access to that. So your friends' decentralized web nodes can connect to your decentralized web node, and then you can share your playlist and you can see your friends' playlist and you can recombine them. And there's access control, so only your friends can access your playlist and not anyone in the world, unless you want anyone in the world to access it. And that is completely decentralized and completely built on DITs, right? There's not one company in the middle that controls all of this, and it's just the DIDs that enable the connections between the decentralized web nodes and that enable the sharing of playlists. That's one of the very cool examples that I've seen recently, but I have to share the link afterwards. I can't find it right now. Did I talk about how this relates to DITCOM? Yes, I think a little bit. If I go back to one of the slides, basically it relates to DITCOM in two ways. The first way how it relates to DITCOM is that in this DIT document, you can look up somebody's DITCOM endpoint. Right, so if I do some live editing of this, you could imagine that the DIT document contains some endpoint like this, and it doesn't actually look like this. It looks a little bit differently, but the point is that if I know somebody's DIT, then I can look up their DITCOM endpoint, and then I can establish a DITCOM connection and exchange DITCOM connection invitations and connection requests and trust ping messages that you have in DITCOM, and requesting credentials and all of these DITCOM messages that can be initiated by resolving somebody's DIT and therefore finding the DITCOM endpoint. And the other way how this relates to DITCOM is because DITCOM contains my public keys, and the DIT document contains my public keys, and your DIT document contains your public keys. And that's how DITCOM messages are actually encrypted and authenticated, because if I know your DIT, then I can find your public key. That means that I can encrypt those DITCOM messages so that only you can decrypt them, and I can sign them with my private key, and you can discover my public key, so you can also verify and authenticate me that the DITCOM message really comes from me. So that's how this fits together, the fact that in DITCOM every message is encrypted and authenticated using the keys that are discovered from the DIT document.
Great. I think those are all all of the questions, right?
Yeah, looks like that. But if there are any more thoughts or questions, feel free to email me, or of course join us in DIF, right? So in DIF, we have the identifiers and discovery working group where we talk about these things. And we're always interested also in new projects and new topics. So if you have something cool to present or some just topic where you need some help, DIF is a very friendly and open place, and we're always excited to hear about new people and new work items. So just reach out.
Cool. Thank you so much. Yeah, perfect, guys. Thank you all for coming and staying and listening in and asking your questions. I will wrap it up there. But thank you so much, and pop a little emoji in the chat to say thank you to our speaker, Marcus. Thanks so much, Marcus, for coming along and presenting today, and rounding off our wonderful workshop series. Cool. All right. See you guys. Bye, everyone.